Land classification and assessment. Ecological sites. The ecological site concept is central to the management of rangelands, and so it is worth taking a careful look at the definition of ecological sites as written by the Natural Resources Conservation Service. An ecological site is a distinctive kind of land with specific physical characteristics that differs from other kinds of land in its ability to produce a distinctive kind and amount of vegetation, and in its ability to respond similarly to management actions and natural disturbances. Now that's a kind of a long definition, but it has very important components to the definition. For one thing, the inclusion of this statement about the ability or capacity of a piece of land to produce a certain amount and kind of vegetation is a key aspect of the definition of ecological site, because we are looking at not only production of vegetation, the amount of biomass that can be produced, but also the species composition that we expect from a site. Also, ecological sites are united in the way that they respond to management actions and natural disturbances. If we consider a management unit such as a ranch, we will often subdivide that unit into pastures, especially if we're managing for livestock production, because the fences and the pastures help us to control the movements, the distribution, and the foraging activities of grazing animals. So we manage vegetation by managing the livestock using pastures in many cases. We could measure within a pasture the amount of forage that is available simply by measuring plant production. But if we're interested in being able to analyze whether or not the sites are producing as well as they could, if they're being as productive as they could be, we need to consider instead the type of land that is in each one of these pastures. We can see here, if we go back to the image, you can see that the land down here in the flat bottomland area looks different than what we see in the uplands, which is different than what we see up here in the woodlands. And it's because of these differences in the site characteristics that we can expect different amounts of vegetation and different kinds of vegetation to be produced on those sites. So if we went back and looked at the pasture level, we would expect to see different vegetation up here probably than we would down there. Okay, so the difference here is due to the identity of the ecological sites. Ecological sites are united by shared characteristics of climate, soils, position in the landscape or topographic position, as well as how they respond to management and to disturbance. One of the key concepts of ecological sites is that they share a site potential. Each different ecological site has its own site potential. Site potential is the capacity of an area or piece of land to support a specific type and amount of vegetation. The potential of a site depends on climate, soils, and topography. And this makes sense because we know that for growing plants, the amount of moisture that a site receives, the length of the growing season, the depth and texture of soils is very important in terms of nutrient relations as well as water holding capacity. And the topographic position of a piece of land is going to influence the type of plants that can grow there. So site potential for ecological sites is important because it reflects the ability of the site to produce vegetation, not only the amount of vegetation, but also a certain species composition. If we were to compare two different sites, what we see here on the left is a sandy ecological site from southern New Mexico, and on the right is a sands ecological site from the Sandhills region of north central Nebraska. The differences in site characteristics, climate, soils, and topography are responsible for the difference in the amount of the potential of these sites to produce vegetation. So for example, in a good rainfall year, if a sandy ecological site is producing at its potential, we could expect it to produce 550 pounds per acre of above ground plant material. On a sands ecological site, in a good rainfall year, if it was producing at its potential, we could expect this site to produce 2,150 pounds per acre. Now that's quite a difference between these two sites, and it's simply due to differences in site potential. Now, if we wanted to evaluate these sites, go out and measure vegetation on the sites, and then say something about the condition of the rangeland or the status of the rangeland, we need to consider site potential. For example, if we were to measure plant production on this sandy ecological site in southern New Mexico, and it produced 500 pounds per acre, compared to the Nebraska site, 500 pounds per acre doesn't sound like a lot, but compared to its potential, 500 pounds per acre is within approximately 90% of the maximum potential available possible for this site. On the other hand, if we were to measure vegetation in a year on this sands ecological site, and it had produced 1,200 pounds per acre, we need to consider how productive that is relative to its potential. In this case, 1,200 pounds per acre is far below the potential for this site, and so we would say that the status of that land or the condition of the rangeland is less in the Nebraska site than it is in the New Mexico site, even though the New Mexico site is producing less. It's producing closer to its potential. The vegetation dynamics of ecological sites are important considerations for rangeland managers. As we said before, vegetation on these sites change and respond similarly to management and to disturbances. Knowing about how vegetation changes is important for managers because we use that information to identify the current status of a site and to predict how well a site is going to respond to management actions or to disturbances. We can identify stable states of vegetation on sites. What we see here for a loamy site are two stable states, a grassland state and a shrubland state, that are possible on this loamy site. There are certain processes that can be management driven or disturbance driven or that occur over time that are responsible for the transition from one state to another. And so we use state and transition models to describe the vegetation dynamics for ecological sites. State and transition models are developed specific for ecological sites. What we see here is a generic state and transition model, and we're just going to briefly review this. In a state and transition model, we see the state is usually represented by boxes, and the state represents a stable state or vegetation community. In this case, the reference state, state A, is a shrub native grass community. We see within this stable state, it is possible to have different communities that may have slightly different species composition, and we may see some change between communities depending on certain factors such as precipitation and other management type factors. But in general, within a state, these transitions between these communities or community pathways are relatively reversible. We can have a transition occur where the vegetation changes from one stable state to another one. In this case, we see a second stable state, state B, which represents shrub exotic annual grass and reduced diversity. We see a transition shown here by this arrow that is the mechanism by which the state changed from state A to state B. We do see within state B there can be some community composition changes that occur within these states, but it's still a relatively stable state. We also see in this state and transition model a third community, the exotic annual grass community, that is represented here and we can move or change from state B to state C through a different transition, which represents different types of processes. We can see also that there is no transition that goes straight from state C to state A or from state A to state C. So this is a generic state and transition model. Let's take a look at a real state and transition model. This is one that was developed for the Gravelly Ecological Site in MLRA 42, Southern Desertic Basins, Plains, and Mountains. The Gravelly Ecological Site has three possible stable states. The mixed shrub grassland state is the historic climax plant community. The shrub-dominated state is an alternative state, as well as the shrubland state. So in most state and transition models, we have multiple stable states that are possible. We can also see, if we look just within the mixed shrub grassland state, that there are numerous different communities that all would be considered a mixed shrub grassland state, even though the composition may be different. So we could have a community that is dominated by tobosa with some shrubs, or we could have a community that is dominated by bush muley or black grama, also with shrubs. And these would still be considered a mixed shrub grassland state. Now, in the presence of overgrazing or summer drought or lack of fire or combination of those, we would see, that's the definition of transition 1A, we could have a transition through a threshold to a second stable state, the shrub-dominated state. In this case, we still have a grass component, but the dominant plant type are shrubs. We could also go from this historic climax plant community through a different type of transition represented by severe overgrazing with widespread grass mortality and erosion that would be a shrubland state. In this case, the composition of the different communities within a shrubland state is predominantly shrubs with very little grass component. Now, state and transition models can get a little overwhelming because there are all these boxes and arrows, and sometimes it helps to think about these in terms of what this actually represents. So here we see one more state and transition model. This is for a Loamy site, again in southern New Mexico. But if instead of looking at these communities and the names of all the communities, if we were to instead replace those boxes with images, this may help to illustrate the point. We can go from a black grama to Bosa grassland through a transition of overgrazing with associated loss of soil fertility and erosion to a burrow grass to Bosa 3-on grassland. And that is the transition that we see here to this state. On the other hand, if we had shrub invasion and overgrazing, we would expect, or lack of fire, that would be transition 2A, and that would lead to the shrub invaded grassland state. Now, if we wanted to know what those community, what the species of the communities were, we would want to look again at the definitions of the species that are found in these different states. Okay, so we can use state and transition models not only to identify the current state of a site, but also to predict how a site is going to respond to management actions and to disturbances. We also use this information to identify sites that are at risk of crossing a threshold, and this may allow us to make timely management actions in order to prevent that transition. We also use state and transition models in order to develop management plans in order to address our management needs on a site. Now, ecological site descriptions are important tools that we use for managing our lands. An ecological site description is a documentation of site characteristics specific to ecological sites. They have 4 main components. There's a lot of information in there, and these main components are site characteristics, plant communities, site interpretations, and supporting information. Ecological site descriptions are developed by the NRCS, and they are maintained on the USDA NRCS Ecological Site Information System website. And we're going to go to that website now to take a quick look at what an ecological site description includes. So here we see the main website for the Ecological Site Information System, and if we were to click on Ecological Site Description, it brings us to this page. We want to go to the Approved Ecological Site Description Reports, and here we have an opportunity to include or to request all of the ecological site descriptions for different MLRAs. I'm going to select MLRA 42. We can also include state. Sometimes if you include state, you get all of the ecological site descriptions for the entire state, and I want to focus just on this particular major land resource area. So by clicking on this, I get a very long list of all of the ecological site descriptions in this major land resource area. And I would like to point out a couple of things. First of all, it's very important to know what site you're on. Now, you have to do that when you are on a site. You need to verify your site identification, and we talked about that in the last lesson, and we will talk about that a little bit more here as well. If you remember from the lesson that we had previously, when we identify a site through the Web Soil Survey, it will give us the name of a site as well as a site ID. And what I would like to point out is that for some major land resource areas, you can have multiple ecological sites that have the same name in English. So here we have a sandy ecological site that is RO42XA and then 051 NM. We also have another sandy site here that is in B, so 042XB. And this reflects differences in land resource units or common resource areas. So when you go to find an ecological site description, you want to make sure that you don't just clue in to the name of the site, but you also have the correct site ID. Now I'm going to select the gravelly site because that is one that we identified when we used the Web Soil Survey to find, to look at soils in order to help us determine what the ecological sites were on a particular management unit that we were interested in. And by clicking on that, it brings me to this main page for the ecological site description. You can access different components one at a time, or you can request the complete report. And I'm going to do that now. It just takes a minute. It just takes a minute to pull up that complete report. And then what we can do is we can just quickly scroll through. Remember, the first are site characteristics. We get information. Remember, the physiography is very important, and so this tells us the type of landscape position that we would expect to see. A gravelly site on an alluvial fan Piedmont, fan remnant, low hills or ridge slopes. It tells us the kind of slope that we could expect to see, as well as the elevation that this kind of ecological site generally occurs in. A lot of this information is written out in a format, in a paragraph form, but also specific data that went into the description are provided as well. The next section is climate. So climatic features, again, we have a paragraph that gives us a description about precipitation, growing season, the timing of the precipitation, etc. And then that is followed by more specific data on a month-by-month basis, what we can expect in terms of the average minimum or maximum amount of precipitation and temperature, etc. If this site typically was associated with surface water, that information would be here. There's also information about the soils. So remember, the soils and topographic position as well as climate are responsible for the ability of a site to produce a certain type of vegetation. And so here we see description about these soils. They tend to be shallow. They also tend to be very gravelly. That's why it has the name gravelly site. Loams. It gives us information about the names of the soil types that are found here, as well as certain other kinds of physical characteristics of the soil, such as depth, as well as soil chemistry. The next main section of the ecological site description is plant communities. And these vary from, depending on where you are in the nation in terms of the amount of information that is included in the plant community section, as well as in site interpretations. But in general, you will find a description about the general plant dynamics that can be expected on the site. There's usually a state and transition model that is specific for the site, and we have seen this one before. This ecological site description also includes some photographs, which is very convenient for determining what state a particular site may be in, and it provides a description about these different states. So there's a lot of information here about the historic climax plant community, as well as other additional states and the transitions that are responsible going from one state to another. Another important piece of information that is in ecological site descriptions, this is very useful when we go to try to assess the current status or condition of the land, is this table of species composition and plant production. Now we will be looking at this in some more detail a little later on when we talk about similarity, calculating similarity. And what we see here is the species that are expected to be found in the historic climax plant community are broken out into different groups of plants. So here we have group 1 is warm season grasses with black grama and bush muley. In a high production year, and that means high rainfall year, we can expect to see 60 pounds per acre on this site from these two species. We see this repeated for group 2, which is cane bluestem, Arizona cottontop, and plains bristlegrass. We could expect to see 30 pounds per acre. We see this written out. Species are put into different plant groups. So we go through the grasses, then the shrubs and vines. Group 7 is solely made up of creosote bush because that is an important shrub species on this site. And we see the species plant production also for forbs as well. Okay, so that is part of the plant community's information. We also get information about the typical plant growth curves, when we would expect to see most of the production, and this site would be in the peak months between May and August. There's also more information about the other types of communities and the states and the vegetation production that we would see. The third component of an ecological site description is the site interpretations. And here we find information about the different types of management uses that can be received from these sites. So there's information about the wildlife habitat, the typical wildlife community. Sometimes you will see information about species by species plant preference of what different animals like to eat on the land. Here we have it for cattle specifically. Certain species are identified in terms of their preference, desirability, etc. There's also information about hydrologic function of the site, typical recreational uses, wood products, and other types of products from the site. We also often will find sort of generic or tabular format stocking rate recommendations for a typical site, assuming a certain amount of production. Finally, we do see supporting information about the ecological site that went into creation of the ecological site description. We will find references to literature and sources of information when the ecological site description was written, as well as information about other ecological sites that are commonly associated with this particular ecological site. Now, if you remember from the previous lesson, there was a discussion that you need to always be careful to identify the site when you are on the ground, because you cannot tell just from a soil map that you can access from the internet what an ecological site is. And that's partly because some ecological sites are they will intergrade spatially with each other, as well as it can reflect the scale at which the soil mapping was done. So in this case, we see for a gravelly site, it is often associated with these other types of ecological sites. If we were to go to our site, okay, so now we're going to go back to the presentation, and if we were to go to the site, we would need to identify what that particular site is on the ground before we can proceed with any type of interpretation. We use ecological site descriptions to inform and guide our management, in part to provide us with information about what we can expect in terms of vegetation dynamics, but also in order to assess vegetation resources on the site. And in order to do that, we have to look at how to determine similarity either to a desired plant community or to the historic climax plant community. Sometimes managers may select a different community as their reference site because of what their specific management goals are for a community. So in order to calculate similarity to a reference community, we compare the annual production on a site either on a species by species basis or on the basis of comparing species groups. Now, ecological sites have different site potential, so remember, comparisons are only valid within ecological sites. When we are calculating similarity to a reference community, the first thing we must do is verify that ecological site. That is very important. We then measure production on the site and determine what the community is for the site, whether it's the desired plant community or the historic climax plant community. We use a worksheet to determine the similarity index. And in this worksheet, we compare the annual production from the reference community that we got from the ecological site description. We also list the actual production of the site by species group. We record pounds allowable and then calculate the similarity index. Now, this has been described for you in the learning guide, and I'm going to go through it relatively quickly. This is very similar to the approach that was taken to calculate a similarity index using the Czekanowski coefficient that was covered in the module on species composition, but it is slightly different. So what we've got here is a worksheet. We've already filled it out with the different plant groups and the names of the species in those plant groups. You'll remember that I pointed those out to you in the when we looked at the ecological site description for the gravelly site. I have listed for a good precipitation year the annual production in the reference community that can be expected for each one of these plant groups. Then, from the data that we collected on the site, we have the amount of production of each one of the groups. So for black grama and bush muley, there was 50 pounds per acre. For cane bluestem, Arizona cottontop, and plains bristlegrass as a group, there was 25 pounds per acre. And that is all recorded here for the site. You'll notice that creosote, for example, creosote bush production is 120 pounds per acre compared to what is expected on this particular site if it were in the grassland shrub state. We then calculate pounds allowable by taking the smaller of these two numbers. And I have highlighted the smaller number in red, and you'll see that that's why we have 50, 25 reported. For group 3, we take the smaller number between 5 and 10 and record that over here. We do that for each one of these groups and then sum that. The similarity index is simply the ratio of the pounds allowable total to the total amount of annual production from the reference community and then multiplied by 100. So in this case, based on the actual production on this site, it is at 83% similarity to the reference community. This is very clearly described in the National Range and Pasture Handbook. This handbook is available as a web resource, and there's a link to it in the learning guide. In conclusion, ecological sites are distinctive types of land that share similar potential to produce vegetation and respond similarly to management and disturbances. They are united by a number of features, one of which is the site potential. Our knowledge of vegetation dynamics is important because it informs management decisions, and the assessment of vegetation resources on a site is specific to the ecological site and is done relative to the reference community.